We did this rush in the last video, and maybe it would be good to take a little more time for this. So this is going to be a video about the midpoint method for calculating the price elasticity of demand. As I said, price elasticity of demand, price elasticity of supply, the same idea. You're just choosing two different points, either on a demand curve or on a supply curve. Okay, so let's imagine we have a demand curve because the price goes down when quantity goes up, and we are calculating it between A and B, and also between B and A. Because with the initial formula, the one that you're presented to price elasticity of demand with, actually works the way that from point A to point B, it will be some value, and from B to A, back to A, it will be a different value. But with this midpoint method, in both cases, from A to B and from calculating from B to A, you'll get the same result. And I'll show it to you right here. So, how does it work? Well, the idea is that the way we calculate it is first, of course, we determine the percentage change in quantity and percentage change in price. But that is where it differs. So, how do we get the percentage change in quantity? Again, difference between the final and the initial. But it won't be over the initial. It will be over the point right between the 2 points. It will be over 2.75, the number right between these two, the average of them. So that's the percentage change in quantity using this formula, this midpoint formula, and then the percentage change in price, that's 1.5 minus 2, again final price minus the initial one, change was minus 0.5, which we will determine and see right here, and then it is again going to be over the point between the 2 points, so 1.75, and you now see how it plays out. Y is going to be the same from A to B and from B to A, and also Y is going to be different than it's going to give a different result than the mainstream formula, than the initial one that you presented to price elasticity of demand curve. So why is it same from A to B and B from A? Because we are dividing by the midpoint. In the initial formula, we are dividing by the first number. So we would either be doing 0.5 over 2 or 0.5 over 1.5. And then we will also be doing either 0.5 over 2.5 or 0.5 over 3. So that's the difference. But here, in both cases, we have the midpoint. In both cases, either when we're going from A to B, we do 0.5 over 2.75 or minus 0.5 or 2.75. But then when one is minus and one is negative, one is positive, then when we go from B to A, it just switches. So one is again negative and the other one is positive. So that's the thing. But otherwise, the result for the price elasticity of demand will end up being the same from A to A and from A to B. Let me just finish this math. So it's 0.5 over 2.75 and we should have price. Yeah, price. Minus 0.5 over 1.75. And we see we're already calculating. So how does this get calculated? Well, 0.5 over 2.75 times, switch this fraction, 175. This cancels out. We take the minus out because the minus is in the denominator. Minus 1 multiplication we can get out. And then we end up with 175 over 275. Indeed, we can multiply both by 100. Scale it up. So we have this, and let's just simplify this. That's going to be 35 minus 35 over 75. No. 55. Yes. So minus 35 over 55, and again divide by 5, so minus 7 over 11. Okay. Yes. So we calculated it. Now, if we calculate it from B to A, the only difference will be that instead of this one being positive and this one negative, this one will be negative and this one positive up here. But the denominators will stay the same. This is the point. That is why from B to A and from A to B it stays the same result. For this method of calculating price elasticity of demand is the midpoint method. And you know why it doesn't really matter which method you use? Because the elasticity is still the same idea. It's just the change in quantity compared to something, and that's why it's percentage. That's because it's to some scale. It's comparison. So already in the ratios, we're basically taking ratios of ratios. Okay, the percentage change in Q is nothing else than actual change in Q, the magnitude of the change over the some chosen value, which can be the initial, can be the midpoint, can be the end value even, but better is the initial and the midpoint. And the percentage change in price is again the change in price, the magnitude of the change, over some chosen value. And so this is exactly what's going on, and that's why this is the percentage. This is going to be the percentage if we divide 7 times 100% over 11. But of course, the elasticity is given as a number. It's given usually as a fraction or something. And here we see that the absolute value, and we talked about this in the introduction to price elasticity, is just 7 over 11, which is different of the minus. And now you see this is smaller than 1. This is smaller than 1, because the numerator is smaller than the denominator. Either way, definition of 1 means two same magnitudes in a fraction. And when the magnitude up here is bigger than 1. When it's smaller than 1, the fraction, okay? So that's the idea, just by the way thing. But we see this is smaller than 1, and so it is an inelastic thing, okay? Good to know that we're calculating this chosen randomly, but numbers close to each other and ended up being inelastic, which was expectable. Okay? So this is the thing, and you might try this yourself. Take these numbers, try to calculate it yourself, have to practice that you also are able to do it.